Hey guys, this is the part 2 of the non-graphing from section 1-3 notes. Although after we do 8, 9, and 10, there is some graphing. So go figure, your math teacher lied to you. All right, parallel and perpendicular slopes. Well, first of all, we always want to have y by itself when we're talking about slopes or y-intercepts and typically graphing. Although we learned earlier that graphing with intercepts is just as good sometimes. But either way, number 8 is in slope-intercept form, so I can officially say that the slope is 4/5. So what's parallel mean? Well, if there's one line, that line is going to ride right alongside him like railroad tracks and never intersect it. So if I were to go up 4 and over 5 to graph that guy, I hope it would make sense. I would have to go up 4 and over 5 to graph that one as well. That was an ugly drawing. But parallel slopes are just the same. So if the slope in your original problem is 4/5, your parallel slope is 4/5. So perpendicular means it would have to go opposite direction. So if the guy tilted to the right is positive, well, the guy I just drew, which tilts left, would have to be negative. And to find a perpendicular slope, it's really simple. All you do is flip the fraction over. So we have to change the sign and flip the fraction. That's how you find a perpendicular slope. Okay, number 9 does not have y by itself. So how do we do that? Well, I got to move the x to the other side. And if I move him, he would be negative. Again, don't let the fraction scare you. It's just a divide by 3. So I will times by 3, times by 3, and times by 3 to get rid of them. So I would think now it's pretty obvious the slope right here is negative 3. Parallel to that would be the exact same thing. Now, negative 3 is understood to be over what? Well, all whole numbers are understood to be over 1. I don't have to write that for my original answer there, but if I want to flip my fraction to get perpendicular, got to flip it. And I'm always baffled as to how people can mess up the signs, because if you think about it, if one line's going this way, the other line's got to go the opposite way. So one's got to be negative and one's got to be positive. So if that first answer was negative 3, that bottom answer has got to be positive 1/3. All right, please, I'm begging you, a memory thing. If it's only an x in the equation, so the y is missing, it automatically makes a vertical line. A vertical line has no slope. Imagine trying to climb up that. You can't walk up that. It has no slope. So another vertical line that would be parallel to that guy would also have no slope. Well, what's perpendicular to a vertical line? Got to be a horizontal line. And again, this is something we'd like you to commit to memory. Horizontal lines have 0 slope. So you could, in fact, take a walk on this line. You just wouldn't change elevation. So 0 change in elevation. But it would be kind of hard to climb this cliff without ropes and whatnot. Okay, so impossible. No slope for that one. All right, so there are some graphs to do. I lied to you. But graphing with parallel and perpendicular. So just given the information, come up with a graph. So if it says 4, -3, it's not like you get a choice. I don't care how you draw the line. It better go through that dot that was given. So always when we're talking about parallel and perpendicular, you're going to want to have y by itself. So the first thing I'm going to do is move that 2x over. And I know my slope is positive 2/1. So the question is, am I using that slope or am I using this slope? Well, you got to look in the directions. That's the symbol for parallel. Parallel means it would have been the same as the original slope. So I, in fact, want to count up to and over 1. Rise over 1. Up to over 1. You know, one more time. If I connect those dots, are they tilting to the right or are they tilting to the left? They're tilting to the right, and that's a positive slope. So I pretty much guaranteed myself of correctly tilting the line. So please, I'm begging you, take the time to consider that. Put some arrows on the end. We're done. All right, number 12. Got to get y by itself. Well, here, -1, -2. Might as well graph that first. But the other thing I have to do is get y by itself. So I'm going to move the 3x over. Okay, now if you think about it, The 17 is pretty unimportant. So if you say parallel lines, there's two lines. There's one I want you to draw and one I gave you. Perpendicular lines, one I want you to draw and one I gave you. So we already have a dot, guys. I don't need that. All I need is the slope. So again, the question is, do I want to go with 3/4 or do I want to flip it and use -4/3? This is the symbol for perpendicular. Perpendicular means flip it and change the sign. So I want to count with that guy instead. So 1, 2, 3, 4 down, 1, 2, 3 over. Notice when I'm going to be done with this line, it's going to tilt to the left. And it better because I had a negative slope. Done. So how easy is this? Well, that was a terrible arrow, but you get the idea. All right, two more to do. 13 passes through 0, -5. Well, where's 0, -5? Coincidentally, it's on the y-intercept, or is a y-intercept. Parallel, so maybe you should circle these guys. Now again, if you remember this makes life so much easier. There's only a y in that problem. If it's only a y, it's going to be a horizontal line. Pretty terrible horizontal line, eh? But I don't even have to put any thought into this. I already know, or knew, because it only had a y in the equation, it was going to be horizontal. So commit it to memory. It's not too much to ask. So if we'd gone perpendicular on that one, we would have drawn a vertical line. Okay, last one. So there's no set of coordinates given, but it does say you're supposed to draw through the y-intercept. And we're talking about the y-intercept of that equation. It's the only equation given. But if you think about it, I don't really have much of a choice here. You got to get y by itself anyway. So let's do that and see what happens. I'll leave the 2y on the left, going to move the 3x to the right. Going to divide everything by 2. Divide that guy in the end by 2. Let's see, that's an 8. Hard to tell. And I get -4. So on this one, yeah, I do have to use this -4 because you weren't given a set of coordinates to start with. So it's saying in the directions, you're going to graph through its y-intercept. Well, here's it, and its y-intercept is -4. Again, y-intercept, do not draw on the x-axis. So the only question is, am I using -3/2? Or am I using, darn it, flip it, +2/3? Which one? We'll go back and read the problem. See this word, perpendicular? Hey, perpendicular means I'm supposed to use the flipped version. So I want a +2/3 slope. +2/3. Which way is that going to tilt? Left or right? So you better have this puppy tilt to the right when you're done with it. So I could go the opposite direction and put a dot over here. Either way you look at it, when I'm done connecting that thing, it's tilting to the right. And we got it. All right, folks, I believe that is the conclusion of all chapter 1, section 3 notes. Let me try to scroll real quick to make sure. Yep, we're at the bottom. All right. Hey, guys, as always, thanks for watching.